Hello everyone. In this video, we will be discussing about design of power screw. So before moving to the power screw design, we should be knowing all these informations, that is a definition, examples, advantages and disadvantages. So how can we define power screw? So it is a device which is converting rotary motion into linear motion to transmit the power is called as the power screw. Examples: lead screw in lathe machines, screw jack, power screw in machine wise, testing machine, presses, etc. It has many advantages compared to the disadvantages. Advantages include large load carrying capacity, compact construction, simple in design and manufacturing, large mechanical advantage, precisely controlled motions, low cost and more reliable, smooth and noiseless working. Disadvantages are poor efficiency, less than 40%, but we cannot say like a new machine will give these kind of poor efficiency. After 50% of its work time, maybe we can expect the efficiency like this. And rapid wear and high friction, these are all the very common disadvantage of the power screws. And before discussing the design procedure, we should be knowing the terminologies of power screws. So here we can able to see we have something called nominal diameter, core diameter, mean diameter, and other things. Nominal diameter is nothing but the largest diameter of the screw. In the picture, we can able to see what is the nominal diameter. Core diameter is nothing but the smallest diameter of the screw, including, excluding the threads. Then mean diameter is nothing but the average. That is the average of the nominal diameter and the core diameter. We are calling as this mean diameter, which is nothing but DO plus DC by 2. And pitch, a successive distance between two adjacent threads is called as pitch. A successive distance between two adjacent threads is called as the pitch. And DC is nothing but DO minus P, or else DO is nothing equal to DC plus P. And lead is nothing but the distance through which a screw advances axially in one revolution of nut is called lead. The distance through which a screw advances axially on one revolution, that is one complete rotation of the nut, we will be calling it as the lead. And the formula to find out the lead is number of starts into pitch. Helix angle alpha, the angle made by helix of thread with a plane of perpendicular to the axis of the screw. And the formula to find out the helix angle is load divided by pi d, that is L divided by pi d. And next one is right hand thread. So when the axis of the screw is vertical and if the thread slopes upward from left to right is known as right hand thread. And left hand thread, when the axis of the screw is vertical and if the thread slopes downward from left to right is known as left hand thread. Then multiple thread screw. When the desired axial movement is maximum at the same dimensional screw, then the number of threads of identical pitch will be manufactured side by side on the rod. Multi-star threads are used when large lead with fine threads or high efficiency is required. Multiple star threads are double, triple, quadruple star screws. So lead is equal to number of stars into pitch. And these are all the thread profile used for power screw, which we already discussed in video 6, where we had a clear understanding of the threads. Here very briefly we'll discuss of square thread. Means the flanks are 90° with the axis of the screw and force applied on both the sides transmits power without any side thrust, used in screw jack and clamping devices. You can able to see this is the application we will be discussing in the syllabus. And moving to the second type, that is the trapezoidal thread. Flanks are 30 degrees with each other, force applied on both sides, used in machine tool, lead screw and power transmission devices, manufactured on a thread milling machine with a multi-point cutting tool. And third one is acme threads. So flanks are 29 degrees. You can able to see both trapezoidal and acme threads are almost look similar except the small flank angle. In case of the trapezoidal it is 30, for acme it is 29 degrees. Force applied on both the sides, used in machine tool, lead screw and power transmission device. You can able to see the applications are same. So manufactured by dies, hence the easy to it is manufactured, and the efficiency is less than the square threads. And the last one is the buttress threads, the V threads, where the flanks are inclined at 45 degrees. It can take a thrust in only one direction. Among the four threads, these three threads where load can be applied on both the sides, but only for the buttress thread where the load can be applied only on one direction, and which is used in vices and clamping devices, and this is stronger than any type of the threads. So it depends on the applications whether we are looking for stronger condition or efficiency, like these type of selection threads will vary. Next, we have certain reasons to use square threads and even V threads. We'll see what and all. So what are the reasons for using square threads in power transmission? So the very first advantages or reason is it is having greatest efficiency due to 0 degree profile angle, because it is exactly perpendicular. So the profile angle is 0 degree, and it produces minimum radial or bursting pressure on the net. It transmits power without any side thrust on both the sides, and more power transmission because of less friction, smooth working and noiseless. These are all the reasons for using the square threads. And what about V threads? It is having greatest efficiency, like similar to the square threads, like even it is having 0 degree profile angle, and it produces minimum radial or bursting pressure on the nut. It is also same thing, and it transmits power without any side thrust on both the sides, even for the same thing. More power transmission because of the less friction, smooth working and noiseless. You can able to see almost all the reasons for the square threads and V threads are same. And what is the difference between V threads and square threads? Means the profile angle, sorry, here it's not 0 degree, it is 60 degree. And moving to the strength, V thread is high due to the thickness of the thread, and the square thread is less because the thread uniform is P by 2. And lower carrying capacity, V thread is having more and square thread is less. Efficiency, V thread is less due to high friction, and for square thread high due to the less friction. Among the four different threads, the one which is recommended for higher efficiency is the square thread. That is why for the screw jack and the lead screw and all, we are using the square threaded screw. And next one is the radial pressure, where the V thread subject to radial pressure, but in square thread it's subject where the radial pressure it will not go under. Manufacturing square thread is very difficult, as we discussed previously. It is among all the threads it is difficult to manufacture, and V threads it is easy. And the cost, V threads is cheaper and square thread is costly, because in the manufacturing point of view the cost is decided. So uh, so these all this informations um, is very much important, and here you can skip the right hand side the information by mistake. The same content has been put on the right side. Correctly speaking, here the first point should be the greatest efficiency. I mean the efficiency is very much less. It is not greatest efficiency because the profile angle is 60 degree, and the radial angle, even the V threads produces more radial angle or the bursting pressure on the nut. Here wrongly it is given, it is not minimum, it is maximum, and transmit power without any side thrust on both the sides, but actually it will not transmit power without any side thrust, because there will be some side thrust on both the sides will be there, and the power transmission will be very less compared to the square thread. And it is not a smooth working, and it is a noise working, because it is a V thread, so we can able to see that the cracking sound always whenever the V threads is used. Even it is possible to hear that sound also for a small screws also, it is possible to hear. So with this we'll wind up this video. Thank you.